Alright, in this tutorial number 11, we're gonna discuss functions, and this is going to be now more of the core things that you really need to understand to use the Moves framework. I suggest you pay careful attention because there are many aspects around functions that you need to understand what methods are, and to understand what parameters are, and to understand what methods do and what functions do and how they return values. So this is a really important session. So please take care if you do not have experience with this material. And I'm going to demonstrate this using the LDT for the moment, not in DCS World because that's way too complicated. Okay, before I am demonstrating, first some theory so you understand. So there is a function scope that is optional valid. So your function can be global or it can be locally to just like variables, right? Function is nothing more than a reference to a memory segment, but the function in comparison to variables, they execute code. So really there you are referring to a code segment. The next point is functions have a name. This is like you know, like identifiers, so you need to follow the syntax of identifiers. You can use underscores and it's case sensitive. The arguments are, you know, placeholders. So arguments can have many forms, many type of arguments, many types, and I'm going into that in the demo as well. Then there is the function body, that, you know, your code that you write. And then return values. So functions can return multiple values or can return one value. Return value is also of a certain type, right? So all of this is going to be a bit too much to explain, but there is excellent reference material on the internet that you can read further, but I'm going to explain you in the demonstration the basics. Right, so let's get to the topic function. I'm going to create a function demo with no parameters, and the brackets indicate the parameters, and the function always needs to start with the keyword function, and it needs to end with the end keyword here. So this is your block. Alright, if I print here in the function, and I'm going to clear this so that you understand what's happening. And I'm going to execute this. Right, so this is my then nothing is being displayed. And why is that? Because the function demo is not being executed yet. It has just been declared. But if I do now here demo between brackets, now my function is being executed. If I run this here, if I put my demo here, and this is important, I got this question from people. Can I just, you know, run a function like this? Where to place the invoke? If I run this here, I get an exception, and the reason is it's a, you know, Lua is a scripting language. It doesn't know where the logic, if the logic hasn't been there yet. So the logic runs like this. So it finds I need to execute demo, but I don't know demo yet. But when I have it here, I know demo what it is because it has been declared here first, right? Same with moves, you know. Remember, when you include your moves file in the beginning of your script, you are executing this complete moves file, and everything in the moves file is being declared. Functions have been declared, the methods have been declared, the objects, the classes. So then after you executed your moves file, then you actually can start using those objects that have been declared. This is a very important concept you need to understand, right? So now I'm in the function. Okay, let me do something else. Let me put a function add, a function that's going to add two numbers, and I have two parameters here, number 1, number 2. Lua is loosely typed. I just need to give these two parameters separated by a comma. No typing required. Now when I do this, what do you think will happen? Well, not much. I still need to execute the logic, which I can do in the print statement. So here I do number 1 plus number 2, and this gives me 9. All right. Okay, very exciting. Now what I want to do is the add. I don't want to do the print here. I want to do the print here. And what I want to do is I want to return the result of number 1 and number 2, of the addition of number 1 and number 2, and print that here. How do I do that? Well, I create a local variable result equals add 4, 5, which is then entered here, and the addition is returned in this function, so it's going to return 9, and that's going to be stored in result here, which is a local variable, so I can print result here, 9. Now I'm going to demonstrate something that's really important in relation to the Moose framework that you need to understand. Remember tables? So if I make a table like a calculator, right? And I do calculator equals this, brackets, and I create a function add, but I want to create actually a function calculator add. Then add becomes a function of the table calculator, and I can call calculator add 4, 5 print result 2. Let me demonstrate this for you. Oh, that should be here, right? And that prints me 9. And this is interesting. Okay, so within calculator, I'm having a table and I'm having a function defined, an add function that I can call, and you see the objects already coming the object-oriented way. So if calculator is my class, I declare my class being an add function, yeah, and that would give me calculator. Now within the Moose framework you see the functions not being declared with a point but with a double point. Now what is that? Well, this is actually more interesting. So what I'm going to do now is I'm going to create here calculator, and I'm going to say the name of the class is calculator, right? So when I do now let me do first double point. So now when I call this way, then an implicit variable will be declared, which is the self variable. So I can do here self name, and I can print that. So self here, this variable, which is a local variable, will actually be calculator, the instance of calculator, and which will contain the name, the string, yeah, name. So the field of calculator will contain calculator as the name. Let me show you this. So this prints me calculator. Let me put that name, otherwise it's confusing. Calculator name. I could also have written this, right? Calculator name. Okay, so you see now that self right, is a variable that's been passed if you use the double point, and that's where the double point is coming from. So any object that I have here, right, any object that I'm having here, if I use that and call add, then I'm actually saying the self keyword here that I get in this function will be the object that I pass there. So when it's the same like this, self. So I can declare a point and I can pass a self keyword here, and that's going to work as well. Or I can do this, point, but then I need to pass calculator again. This is going to work as well. So remember that functions can become methods if you use the double point syntax, and that implicitly declares a self variable within the function that's being used within the Moose framework to identify the actual table or object, as we call it. So yeah, that's been passed as part of the function. Yep. And this is how Moose works internally. This is how object-oriented is being done. Of course, a bit more difficult than that, because then you get inheritance and all of this, but I need to explain that when we get to the objects. But this is how the actual method mechanism is working. So I hope you found this interesting, and there's documentation on the internet available where you can read more about these subjects. So thanks for watching. Bye bye.